I'm Ben Hadden. I think it's worth saying sort of off the bat that I am not an AI researcher. I'm just a software engineer, but I am a software engineer who has been interested in network protocols at CNRI for the last 15 years or so, and in particular network protocols that are interested in promoting data interoperability. Uh, so Anthropic at the end of last year released a new protocol called the Model Context Protocol, MCP. And they said that this was about promoting interoperability. In particular, they want interoperability between AI systems and sort of disparate data systems. And so we thought, well, that's interesting. Perhaps we've got some overlap there. Maybe we should take a bit of a look at this. And I want to read you a quote from some of the materials they published when they released this protocol, because I think it's telling. So yeah, even the most sophisticated models are constrained by their isolation from data, trapped behind information silos and legacy systems. Every new data source requires its own custom implementation, making truly connected systems difficult to scale. MCP addresses this challenge, provides a universal open standard for connecting AI systems with data sources, replacing fragmented integrations with a single protocol. The result is a simpler, more reliable way to give AI systems access to the data they need. And so when we read that, we were a little bit struck because I think I could have written that statement years ago and probably have written very similar paragraphs to those over the years. So we're like, okay, there might be something here that's interesting for us. And in particular, we were like, could we create a mapping from MCP to the protocol that we've spent a fair bit of time on at CNRI, which is our DOIP Digital Object Interface protocol. And indeed, there's a mapping that actually fits quite cleanly between those two. There's a part of the MCP protocol. I suppose I should step back just a little bit. One of the major roles of the MCP protocol is to allow the LLM that you're interacting with at prompt time, so not training time, this is at prompt time, to allow that LLM to invoke tools to retrieve data, or perform operations on other services that might be running locally or remotely while you're having a conversation with it. And so you can imagine that with DOIP, we have operations, and with MCP, they have tools, and there's some mapping between those two things. For each MCP tool, it gets a unique name, a human readable description, which is actually interesting, and I'll get back to that in a moment, because actually that does a lot of the heavy lifting in this world, but also a machine readable description of the required input for the tool, which is defined by JSON schema. So you can see it's actually a very simple constrained protocol. And there's one other thing I want to just say a few words about here, which I guess sort of dovetails on a little bit to what Christoph was saying about a previous demo I gave using Jupyter notebooks. So over the years at CNRI, we've built quite a lot of user interfaces for interacting with sort of this world of sort of remote network accessible objects. And those user interfaces have always been somewhat complicated. There's never been like a very simple user interface that someone with no training could just pick up and use. And I think, like, Jupyter Notebooks is a fine example of that. That's great if you know a bit of Python and you're familiar with Jupyter Notebooks, but if you're not a programmer, that's essentially not accessible for you. And it might just be that, like, the LLM chatbot is sort of the killer app of user interfaces for interacting with this kind of disparate data, and maybe MCP is sort of the glue that brings all that together. Okay, so I'm going to give you a demo, assuming the demo gods are smiling on me today. It'll be a live demo of some software that we've written, and it'll be interacting with a number of moving pieces that I haven't written and services that are run by other companies. So hopefully the gods will smile on us. If it doesn't work out, I've actually got a video that I prepared earlier just in case, but I think fingers crossed it should go okay. Let me just give you an overview of the components of this demo. Running on my local machine will be the Claude desktop application. This is software provided by Anthropic. It's a chatbot user interface to the Claude LLM. We'll be talking to Claude Sonnet 4 this time, which is running on Anthropic's servers remotely. The new piece that we're demoing here is the DOIP MCP connector. And that's software that runs locally and its job is to interact with the MCP tool requests coming from the LLM, translating them into DOIP, sending them to a DOIP service, and doing the reverse translation on the way back. But it also has this other job of sort of discovering what operations are available on the DOIP service and sort of informing the LLM what operations are available so it can know what sort of things it can do with the remote service. And then the remote service in this case is an instance of the Cordra software, which is our digital object server, which runs the DOIP protocol. In this case, that Cordra software is running on a Raspberry Pi. In the office that I'm in at the moment, we've got a number of other servers that we run on premise, and those are in a different room. And we're somewhat concerned about the temperature in that room. And so this Raspberry Pi has some hardware sensors on it for measuring the temperature and the humidity there. And those hardware sensors correspond with digital objects in that Cordra server so that you can perform some custom operations on those objects to read the current temperature or get the history of a particular sensor, that sort of thing. Okay, so we do intend to make this MCP connector software available for other people to use, and it would take a little bit of configuration. But assuming that you can download this MCP connector software, you have to configure the Claude desktop app to use that MCP connector, which is just a small JSON file. You have to configure the DOIP MCP connector to talk to a particular Cordra or DOIP service, and you specify at that point which credentials it should use when it's talking to that DOIP service. So you can restrict the sorts of things it does just using the usual access control that DOIP services provide. Out of the box, you get the basic operations. So you get search, create, retrieve, update, and delete. Those are all automatically supported. Although you can, through configuration, disable create, update, and delete if you don't want to allow your LLM to be modifying data in your repository. And then if you've got any custom operations that you want to expose to your LLM, you just sort of drop in a little bit of extra configuration for each of those operations, where that extra configuration is just giving each operation a human readable description and the machine readable description of the inputs that it needs. Okay, so let me jump out of here, and here we are looking at Claude Desktop. I'm sure you're all familiar with what an LLM chatbot looks like today, and this is Anthropic's version of that. So similar to sort of ChatGPT and friends. So when it starts up, it hasn't yet sent any requests to the DOIP service, but we can ask it a simple question. We can say, can you type, tell me what types you see in Cordra? Okay, so I'll talk through what it's doing here. So we can sort of see here, this little bit of user interface that it shows here is what you see when an MCP tool has been invoked. And you can see that it realized that it needed to invoke the search tool from this prompt. And that search tool corresponds to the search operation in DOIP. And it figured out from the human readable description and from the machine readable description what input needs to be given to that search tool. You can see it's like, oh, this takes JSON, it's going to take a query property. And it's even figured out that in order to sort of satisfy my natural language prompt here for like what types are available, it figured out what query it needs to send to Cordra to sort of get some answer to that. And it was able to do that because the human readable description that Cordra gives it for the search operation, the search tool, is actually quite verbose. Like, to a first approximation, I just copied 10 pages of text, human readable text, out of the Cordra documentation that goes into some detail describing the Lucene query syntax, what the structure of objects are, how the fields of those objects are indexed. And so just one useful thing that sort of fell out of this is that you get something like a natural language user interface for querying a system without having to know the specifics of the query syntax for that system. The language model can do that for you. And then you can see the result of that search as much as you might expect, right? We've got a big chunk of JSON that a human can read, but it's a lot for a human to parse. But the LLM parses it for us, and it gives us a summary here of the types of objects which are in Cordra, which is what we asked for. And we can see that there's groups and documents and users, which you get in all Cordras sort of out of the box. But we can see there's also sensors and sensor readings and multi-value sensor readings, which are these sort of specific types to this particular Cordra instance. And we can even see that it recognizes that for sensor types, there are built-in operations for those. We've got read sensor and get sensor history for those two there. So I'm going to ask it another question. I'm going to say, what sensors do you see in Cordra? So first we asked what types are in Cordra. And now I'm saying, what specific instances of sensor objects do you see in Cordra? And you can see that it was able to figure out again that it needs to run a search operation. And this time is asking for objects of type sensor. And it got back some results. And we've got 3 objects back as a big chunk of JSON. And we won't read the JSON, but we'll read the LLM summary of that response there. And we can see, okay, we've got a server room sensor that's measuring humidity. We've got another sensor that's not currently in use. We've got a temperature sensor. Yeah, so then we might say, and you read the temp sensor. And I think this is where it starts to get a little bit interesting. Let's bring that open again. It figured out from that prompt that it needs to invoke the custom read sensor operation. And the input to that operation needs a target ID. It doesn't need any other custom input as well. And that target ID is the unique ID of the object that this operation would be performed on. And it was able to sort of reason that the target ID needs to be for the temperature sensor. And from the search results that it got earlier, the temperature sensor has this particular target ID ending in B09. And so it sort of feeds that in as the input for this read sensor operation. And sure enough, we got a response back, another chunk of JSON, which has a value of 23.2. And moreover, there's no units on this result here, but the sensor object itself tells you what units it produces values in. And the LLM was able to sort of correlate those two here. So when it's giving a summary, it knows that 23.2 is in degrees Celsius, and it automatically gives you, a conversion to Fahrenheit and recognizes that there's a timestamp on that. And it even gives us it even thinks that the temperature in the server room is within operating ranges. Let's just ask it to get the humidity as well. And so it's again invoking the read sensor operation, and this time it's passing in a different ID. This time it's the ID of the humidity object, and this time we get back a value of 59 and some change, which again is it's on the humid side, but acceptable for my purposes. We can ask what else can I do with a. Sorry, my typing is brilliant this morning. So again, you can ask an object, what can I do with you, right? And we've got some operations here for deleting old sensor readings, but I suppose I'm interested in this this operation here of getting a sensor history. So can you get the temp sensor history? For the last 24 hours. And so from that little prompt, it figures out that it needs to invoke this other operation, about getting the sensor history. And if you look at that, it's sending it to the right object. This operation actually does require some sort of custom input, which is sort of the the amount of time in milliseconds in this case for how much history that you want. And so it was able to figure that out from, that combination of human readable description of how to use the operation plus the JSON schema for the input of the operation. And the response that it gets back, as you might imagine, is a long list of sensor reading values, timestamps corresponding with values there, and it gives us a summary of that data. It calculates things like what the average, the min, the max were. It even makes some observations. Look, it's very stable, doesn't vary too much. Seems to think everything is going well. So let's see. I could ask for, can you get the history for humidity as well? Just to show that, like, it's able to then target a different object. This time it's targeting the humidity sensor, and we'll get some similar results back about the historical humidity there. Okay, so when it finishes that, I'm going to, as a bit of a sort of a stretch goal of this demo, and give me a little rope here, because LLMs are not exactly deterministic. They don't always respond in exactly the same way to the same prompt. So it sometimes fails on this, but I'll ask it to do it anyway. I'm going to ask it to sort of render that historical data in a graph or a dashboard for us and see if it can go off and write some software while I keep talking. So can you render that history data in a dashboard? And let's see if it actually even makes progress with that. Okay, so it's off there writing some software. It's not particularly quick at writing software, so I'll say some words while it's doing that. So that's a demonstration of custom operations, but you also get the basic sort of search, retrieve, create, update, delete operations. And so you could have documents, sort of human readable documents, PDFs or Word files or whatever, stored in your repository, and you can retrieve those, bring those into the context, have a conversation with your language model about those documents and reason over them. And I'll just give us a little anecdotal story here as well. So I've been playing with this stuff a little bit over the last month. We were contacted by some researchers who wanted to publish their data recently, and they were asking for some assistance in that. And they had been they'd been looking at the sort of the genome of the COVID virus, making modifications to that and running simulations on those modifications. And they had a big data set, a CSV file with, I don't know, 4,000 lines in it or so. And they wanted to publish that data in such a way that each line in the CSV file would get a unique identifier, and they wanted people to be able to search that data and make it available for people. So I copied into the LLM a document they'd given me, a complicated, quite technical document that described the project they'd been working on, and I also gave it the CSV file and asked the LLM to produce a JSON schema that represented their data, and it did. It produced a pleasing JSON schema along with some human readable descriptions for each of the properties that would be in the JSON. And then I asked it to just create a new type in Cordra using that schema, and because it was able to use the create operation, it just happily did that and created a type in Cordra that has worked first time. And then I asked it to write some software to translate the CSV file into JSON objects that corresponded to the schema that it had just created, and it was happily able to do that, and we inserted those into Cordra. And I think what stuck out was that within a morning's work, really without writing a line of code, we were able to go from a CSV file to to published data with unique identifiers for each row that was searchable, with data that conformed to a schema and was validated against the schema there. And yeah, it was interesting. So this is rather disappointing. Claude seems to have failed at producing that dashboard. Let me just ask it again. It might have some success. Didn't seem to work. All I see is a loading screen. But the demo here is not about Claude's ability to write user interfaces for us on the fly. It's more about the sort of the interaction between the two protocols there, DOIP and MCP. And while it's doing that, I just sort of want to go back to this first slide where there was a quote from Anthropic here, and sort of consider the question: why did Anthropic decide that a new protocol was appropriate here? And you sort of see this in the forums where people are talking about MCP all the time. They're like, why didn't we just use HTTP? We can already describe our protocols with things like Open API. Why do we have to have a new protocol? And I have some personal thoughts on this matter, on the topic of interoperability in protocols, and in particular why HTTP is in many ways an impediment to interoperability. And it's this line here: every new data source requires its own custom implementation. And I think we need to be careful. Like, we should be thinking that HTTP, at least for anything except simple HTTP GETs, is really just a transport protocol. And every time we build an HTTP API on top of it, even if we describe that API with Open API, we're really building a new protocol that is incompatible with all of the other protocols that are already out there. And that's okay. You can still do that. And we've done that for, gosh, 25 years now. And software engineers can interact with these new HTTP protocols. We can write software to talk to them using the same transport. But it's pretty terrible for automatic machine interoperability. And let me sort of give you an example of why I think that. If say you wanted to invoke some functionality on some HTTP server, just call a particular function and return the result. You've got to encode somewhere in the HTTP request where the name of the function goes, right? And you've got so many options. It could go in the path. It could go in the query parameters. It could go in the body of the request. And if it goes in the body of the request, you could serialize that as XML. You could serialize it as JSON. You could serialize it as form data. And then you've got the same set of questions again for where the input goes. Does that go as query parameters? Does it go in the body? How do you serialize it? Does it go in the request headers? And because you've got all of these options, you sort of guarantee that everybody's going to do it slightly differently. And that's where the lack of interoperability comes from. And my conclusion, having worked on DOIP and other protocols over the years, is that you need to constrain people's options without restricting their expressiveness. And I think we do that relatively well with DOIP. In some sense, I think DOIP doesn't quite go far enough in the constraint direction. But in my ideal world, we get to a place where when somebody wants to publish their data, they shouldn't be thinking about questions like, how do I want to serialize this? And what goes in the path or the query params or the headers or any of that. All they should really be thinking about is like, what's the type of my data? And are there other communities out there who've already agreed on a particular shared type for that data? And then we should provide the tooling that makes it easy for them to just publish their data using that type with a sort of a container like DOIP, particularly DOIP over HTTP, that gives you the sort of the uniform way of interacting with it. And I think that's roughly why Anthropic went down this path of a brand new protocol, because it forces people to do it in this uniform way, and HTTP wouldn't have been that. Anyway, so I hope that I've not sort of overstepped the mark there with my quite strong opinions on HTTP and interoperability. There's a mine and mine alone. But yeah, that's my demonstration. Happy to take any questions.
I was curious, did it end up rendering something in the
Oh, yeah, we should go back and have a look. Did it manage? Oh, yeah, it did. Look at that. It has rendered something in the end here. We've got a title. It rendered the current temperature and the humidity and the range, and it's plotted a graph there of the temperature and humidity trends, and even combined them in another little chart at the bottom. Yeah, Lovely. Thank you, Claude. Didn't completely fail me.